This is a two-part challenge. Cameron,
Uh-huh.
read this.
The FOOF went FOOF when I spilled it on the floor. Now I have to explain the crater to my landlord.
Now explain it.
FOOF is a substance that has strong objections to existing.
What is FOOF exactly?
FOOF is it's an onomatopoeia for a compound that is dioxygen difluoride.
Mm-hmm.
Basically, it's something that really, really, really would prefer not to be. So it's how do I even describe it?
It's a compound that, while you can make it stick together, what it would like to do is not be stuck together.
Yeah,
right?
it has too many things.
Mm-hmm.
It has too many things, and would really, really rather just be in pairs of those things.
So when it reacts to try to do that, how does it do it?
It energetically forms new bonds with anything around it.
I see.
And then that causes a lot of, heat and new things, new gases forming, right? Like the stuff in your airbags, right? It's a solid. It's an azide, right? And azides are nitrogen rich. Most explosives are really full of nitrogen, right? And the reason for that is that nitrogen really prefers to bond with other nitrogen instead of other things.
N would prefer to be N2.
Yeah, it prefers to be N2.
Okay.
Right? And the thing with molecular nitrogen is that it forms a triple bond, which is a really nice, strong triple bond.
Yeah,
right?
yeah.
It's very strong. Nitrogen it's not inert, but you can get away with using it as an inert gas in a lot of scenarios because it's dirt cheap. Right? If your lab doesn't want to spring for argon, then nitrogen for most purposes is fine. So that bond is really difficult to break, and which means that when you form that bond, it releases a lot of energy because it's happy making it.
Right.
Right? You get a huge amount of energy out of it, which means that it's explosive. FOOF is like that, only more so. And I think FOOF was made basically on a dare. I can't imagine any other reason why you would ever make something like this.
Right.
And it's not, like, this is on the list of things that guy will not work with.
Yes.
It's
Rockbusher indeed even linked to it in chat.
Oh, yeah, it's just dangerous and it doesn't do anything useful.
Right.
I mean, it oxidizes things, but so do a lot of other things.
So is it because the amount of heat it generates is that when all the oxygen decides I want to be O2 and it's like, oh, look, I'm O2 again, and all this energy has been created, I guess what I'll do is combust.
Yeah, well, it stops being one molecule and starts being like four molecules, and then fluorine is really reactive, oxygen is really reactive, and they'll react with other things if in the presence of, I don't know, heat.
Neat.
Right? The kind of heat that's generated when you form four molecules out of one molecule. And they all have to occupy way more space than they did before. Right? It cascades outwards, right? And it reacts with other things. And it's bad, right? I mean, when I say nobody should ever work with it, there are probably situations where you could find that you have to make FOOF and use FOOF. But I can't imagine them right now because it's volatile and unpleasant.
Like me.
I don't believe that for a minute.
Like a couple of years ago, there was a fire in the port of Vancouver where the containers caught fire. And as a lark, somebody asked me, like, hey, Cam, there's a lot of stuff burning in this container. If you knew what was in the container, could you tell us what kind of chemicals would be released? And the thing with combustion is that it's very messy, right? Like, you all remember grade 9 chemistry, right? Where it's like, say that you're burning hydrogen gas. And hydrogen, H2, reacts with oxygen, H2 underscore, or subscript G, plus O2 subscript G, arrow H2O, right? And then you would have to balance that equation.
Yeah.
The thing is that there's a ton of other side reactions that go on because when you start burning things, you create heat, and that heat allows other reactions to occur. Like when you burn gasoline in your car engine, right? Say you can abstract that to burning ethanol,
Right.
C8H
Left.
16H. No, it would be like H20 something. That's a fairly straightforward reaction. Carbon dioxide and water,
Okay.
right? Only no. There's a bunch of other things that you're forming there because maybe the ethanol doesn't all react and you get like or hexanes and benzenes forming. And then that's presuming that the oxygen is the only gas in there. And we just established that the atmosphere is mostly nitrogen. And that nitrogen's pretty stable until you start exposing it to a lot of heat like it is in a car engine. And that's where you get acid rain from. Acid rain, nitric acid, is the side product of combustion in car engines because that is what happens when you have atmospheric nitrogen reacting in a reactor, i.e. your car engine, under tremendous heat and pressure.
Huh. That's the only part of that I understood.
Oh, I'm sorry.
No, but I wish that I understood more.
Well, we have some memes for you then. Hey, Sodium, can I have an extra electron for stability?
Sure.
What?
Salt time.
I need to hang out with them more.
C8H23, right, ethanol. Oh, wait, that's ethane. Ethanol has an OH group in there, so it'd be like C8OH, no, H23 still.
It is super interesting. I was like, I wish I understood this.
Mm-hmm.
One day.
Sodium walked up to chlorine and said, "Hey, do you mind if I borrow an electron?" And chlorine said, "Are you sure?" And Sodium was like, "Yeah, I'm positive."
Okay, I get that. I get that one.
Worm apotheote, that's also probably likely. Nitric acid is only one of the acids probably found in acid rain. I wouldn't be surprised to find out that there's also sulfuric acid in there as a similar byproduct of burning coal or natural gas, right? Incomplete reactions of natural gas. You know, those piles of sulfur in Vancouver.
They're so beautiful, though.
Yeah, I love Andrew's story about how he tells people who are new to Vancouver, like, hey, what are those big yellow piles? And I think his story is that, well, there are 16 Crayola cities in the world. Actually, I'm spoiling Andrew's story. I won't tell his story because it's a fun story.
All right.
They used.
My story.
It's your story.
My story.
Really?
Did you want to tell
How
that story?
scandalous.
Sure.
Okay.
Tune in tomorrow where Andrew tells Matt's story.
So, of course, Vancouver has the big yellow piles of sulfur. And when you are introducing someone new to the city, it is customary to try and pull one over on them briefly. And I've done this. So I went to do grad school in Vancouver, and of course the program that I was in was very international. So we had a whole bunch of people from all around the world. And of course, when the weather got nice, we all wanted to go to Stanley Park, and you can see the sulfur piles from Stanley Park. So biking around Stanley Park, everybody's like, oh, you know, look at the sites, and then you point out the piles of sulfur across the Broad Inlet, and you say, hey, do you know what those are? And they all say, no, I have no idea. What are they? Well, you know Crayola crayons, right? Well, they make a different crayon in each city. So, like, Crayola has factories in cities around the world, and
Right.
each city gets a different color.
Right.
And Vancouver's color is yellow. And then they'll be like, really? And you're like, yeah. And you know, they get the pigments from chemicals that are local to wherever. And,
Right.
You know, the head office, and I don't remember at the moment, but it's like Sacramento or something,
Yeah.
or something, right? It's like, and their head office is here, and so each city takes advantage of like the economies of scale of only having to produce one color, and then it's more cost efficient for them to make the crayons in the city that does that color, and then ship them to the head office where they're all packaged and then shipped back out to consumers. And they'll be like, really? Wow, that's really interesting. Really? And then you go, no, of course not.
Yeah, you're like, ha, I fooled you, idiot.
And then, you know, you tell them, of course, that it's sulfur, and you like, it's all just about selling the story, right? But it's a way to have a little fun with people about
Truly,
something.
you have been bested by my japes.
Yeah, exactly.
And sorry, I realized reading chat now that I was saying gasoline has ethanol in it, which is true, but what I meant to say is octanes,
Yeah.
Yeah.
right? And
Yeah. Because
and, like, there's no, if you, gasoline is not one molecule.
It sure isn't.
It's a mess of different things, right? Like when I say octane, right? There's a bunch of different ways for octane to be, because that's how it do.
Right.
And then there's octenes and octines and all kinds of different combinations of those. It's a mess. It's
And
just a complete mess.
Something I love about that is that diesel as a fuel does not contain octane in the same way. It is largely cetane.
Oh.
Yeah, it's 7 and rather than
Or
8.
heptanes.
Heptane or whatever
Yeah.
it is. Yeah, it's like it's one. No, I think it's cetane is what they actually write on the, because you can
okay.
dump cetane booster into your diesel to increase the level of cetane that's in it.
Oh, okay.
And that's supposed to improve combustion. I actually don't ever use it because I'm like, I don't know why I would even bother doing this. But you definitely don't dump that into your gasoline tank. You use that in a
Yeah.
diesel tank instead.
Right, okay.
And because the
Okay.
yeah, it just happens to be two different things that, you know, I was, yeah, go right ahead. I was actually gonna, there's another one that, can we roll in on a challenge while you're searching for something, or do you want to actually, we should stay on this topic so you can find the thing that you're looking
Yes,
for.
just because I want to send this to. I just want people to be able to see the image because it's interesting.
Yeah.
But I want to get a nice picture from Stanley Park, so
Yeah.
you get the angle.
The sense of what it is that you're looking at. It's funny too because I'm pretty sure that there are giant sulfur piles in Fort McMurray.
Which I've driven by. They're more block shaped. They look like houses and apartment blocks.
Yeah, I think were those the ones that were being posted in chat?
Yeah,
They
someone put
might
them
have
in
been.
chat.
Those are the Fort Mac ones, yeah. Which is why when I saw them, I'm like, you can see that from Stanley Park, because that sure does not look like anywhere near Stanley Park.
Yeah, no, what goes on in oil refineries is just dark black magic.
Go over color. I've gone too far down the hole. I should have
no.
just. I should just
Specifically the
that
cracking
one.
areas.
That's fine. I'm just gonna send you this image. Engineering,
Maybe.
maybe.
You're very close to 250K.
Yeah,
You're very
a little over
close.
500.
Striking distance.
Can we do view?
No, but I can save it.
Yeah, 20 block.
Oh wait, but that's the
Those
wrong way to save it.
941 and increments up in there.
Images.
You also have them in Swassen, right?
Swassen has
Yeah.
coal.
Coal?
There.
I want to say that I used to be able to see sulfur there, but they might have moved it just into. Yeah, I guess so.
There we go.
I mean, I haven't been there for years. So.
Can we get that on screen? The one that
Yeah.
we just posted to engineering.
Oh boy. Oh, it looks like somebody's posting a picture of it from Stanley. Crusher, of course,
Yeah.
has a picture of it
Yeah.
from the seawall, but this will also work because,
This one everyone can see.
yeah. So you're going around Stanley Park. That is what you can see from Stanley Park.
Oh. I would believe you.
Yeah, and from the distance, it looks like
Yeah.
a factory making yellow stuff.
Whereas we have something much like that, or I guess they have something much like that in across the river in Edmonton, except they call it the Butter Dome. The U of A has a giant yellow building that is.
it's the auditorium, right?
No, it's a sports complex.
Oh, okay.
Yeah, the Van Vliet Center, colloquially known as the Butter Dome, because it's a giant yellow building, and it's like yellow metal.
Yeah, it's enameled metal panels.
Yeah.
But they do round the corners at the top, so
Yeah.
it looks like a pat of butter.
It's actually, I find it striking and beautiful in its own way because it really does stick out.
It was a very interesting piece of architecture for a university that had no interesting architecture for a good 2 decades.
Yeah. I'm glad they did something like that.
I
So
think it's what stopped the interesting architecture because people hated it.